Okay, you always need to have at least one cable and likely one or more switches to create a network. Even in a wireless network, you will usually have a cable from the internet provider to the wireless access point. Even if you have wireless access from your internet provider, you will still have a cable going from your internet provider's radio to your internal wireless access point. Your router needs to have access to your internet connection. For a home user, that will usually be a cable modem or a DSL modem. For an organization, it may be a T1, T3, or even a fiber line. You want to place wireless access points to where you have maximized wireless coverage, which is typically going to be in a central location, ideally. Switches need to be placed near areas that need multiple network connections, as well as to increase the distance from the internet connection. Remember, Ethernet has a maximum of 100 meters before needing to be regenerated. And to regenerate the signal, you can do that with a switch. Wall jacks are connected to switches located in your wiring closet and server rooms. So the wires in your walls usually will go back to your server room, and you'll have RJ45 ports in the wall jacks. All right, it's best not to exceed 100 meters in length for Ethernet twisted pair cabling, because that is its maximum distance, and you'll get very spotty connections. You'll have packet drops, things like that. It'll be corrupt. It may work, but you'll get spotty results. So the closer you are to 100 meters, the more likely you'll have issues with Ethernet. So stay under 100 meters. Use category 5E or higher. I would even go as far as using Cat 6 or higher, especially in today's networks. If I was building a new network today, I would definitely go at least category 6 or higher, so it'll be compatible for longer, because we're getting into higher end speeds, especially with the new wireless ratings. It's going to soon be at 10 gigabits for wireless, so you're going to want category 6, which is capable of 10 gig speeds on your local area networks, or higher, right? Use switches rated at the same speed as your network adapters. For gigabit speeds, you'll need to use gigabit switches, adapters, and routers. Always plan your network before you build it out. Here's just a physical plan of a typical small office here. You have some switches, you have a cable modem, you have a network printer, you have some Ethernet wall jacks as well. But knowing it and planning it out, and seeing how long cable runs you need, what do you need, is a good idea to do before you start building it out. Several tools that you'll need as a network technician. Loopback plug used to test a network cable or port. A cable tester, definitely, I would say a cable tester is going to be way more important than a loopback plug. And you can find out what type of cable, if it's not labeled, and to locate the ends of the network cable in the building. It's just good to have. It's got, we'll show you here on the next slide, but it's got a remote and a base, and allows you to test different types of cables. The network multimeter can test cables, ports, and network adapters. Right, you can detect. Uh, well, the multimeter, yeah, you can detect the speed, the duplex. Um, I don't know how it's going to detect the default router on a network, but it's definitely going to um, help you with the voltage levels and power over Ethernet and other network uh, statistics. And it can document the test results and upload these results to your computer. Here is an example. This depicts a cable tester where you plug one end uh, of the cable into each of the blocks and then switch it on to determine if the cable is good or bad. Um, this is good for just making sure the cable is good. It'll light up. A lot of them will show all 8 wires, and if they're correctly wired, and if they're still good, if you're getting signal all the way through the cable. Wi-Fi analyzer. It's definitely useful. Helps you determine signal strengths. Help you identify any security threats. You can turn your smartphone into a Wi-Fi analyzer by installing free or inexpensive apps. A toner probe. It's a 2-part kit. The tone generator and the probe. And this is used to find cables in the walls, find out which cable is going, so basically for your wall jacks, where in the server room do they go, right? Which wire in the server room is the wall jack in room 22, right? That's where the tone generator and probe are good. Put the tone generator in the wall jack, and then you go in the server room and you touch the cables with the probe, and it'll generate a tone. You'll hear a tone when you find out which cable is actually going to that outlet. So it's really useful. Cable stripper, used to if you're building your own network cables. It'll cut away the plastic jacket and it'll give you access to the wires. Crimpers are used to attach the cable in, like the RJ45. Then finally, you have, if you're not going to use the RJ45, you use the punch down tool to punch down the individual wires into slots. It's used in the server rooms. So the wall jacks, that go back to the server room many times, they'll go back into the server room and get punched down. Instead of putting RJ45s on all of them, they'll be punched down into a patch panel, and then there'll be a RJ45 socket available from that punch down. This is an example of the Wi-Fi analyzer, which has detected 3 wireless networks. But it'll help you know what channels are being used and what other Wi-Fi is around. And you can see that it's got the SSIDs available as well that are being broadcast. This is a tone probe tool that can help you locate a wire in a large wiring closet, which may have hundreds or thousands of wires. You connect one end of the wire to a port, and it sends a tone across the wire, and then you take the probe, and when you touch it to the wire, the tone that the generator is plugged into, you'll hear the tone letting you know that that is the wire. Think of it as being used to try and determine which cable in your server room goes to the wall jack in a room down the hall. You would connect and turn on the toner in the room down the hall, and then go into the server room and touch each cable until you hear the tone. And this lets you know that this cable that goes from the server room to the room in the hall. Here's an example of wire crimpers. This allows you to connect RJ45 or RJ11 telephone cable connectors at the end of the cable. It's also got a wire cutter available, so you can cut the cables. And this is a punch down tool, and you use to connect the wires in the punch down board, which is one way to terminate wiring in a wiring closet. The other would be with the RJ45, but in the server closet rooms, a lot of times you use a punch down tool for the wiring. Now you have straight through cables, which is what most always you will find these. I mean, it just straight through cables are so named as the wires on each end of the cable are the same, whereas crossover cables, the transmit and the receive lines are reversed on each end of the cable. You used to need a crossover cable anytime that, but nowadays devices are smart enough that they're not as necessary as they once were, but you can still use them and might need them when connecting like devices together, such as a switch to a switch or PC to a PC. You would need a crossover cable in those instances. Many times though nowadays, but you also, like if you went a PC to a router, you would need a crossover cable, but many times the routers are smart enough you don't need a crossover cable anymore. RJ45 has 8 wires, right? Only 4 of which are needed for 100 megabits or lower speed. So if you only want 100 megabits a second, you only need 4 of the wires. You need all 8 wires for gigabit speeds though. The wires are color coded, and there are 2 standards for connecting the RJ45 connectors. The T568A and B are the standards. This shows the 2 different wiring standards. The only difference is which pins that the green and orange wires connect to. So you see in the A wiring, green is on pins 1 and 2, and orange is on 3 and 6. Whereas in the B wiring standard, the orange pair are on 1 and 2, and the greens are on 3 and 6. But blue is always on 4 or 5, and brown is always on 7, 8. And this just depicts in a table format what each pin does and which color is connected depending on which wiring standard that you use, right? So pins 1 and 2 do our transmit, 3 is receive, 4 and 5 are used with gigabit, 6 is receive, 7 and 8 are gigabit, right? So our blue and brown wires are only used in gigabit transmissions. Our orange and green are what are in the transmit and receive wires. However, it really doesn't matter what color you put on what pin, as long as the same wire is connected to the same pin on each side of the cable. It will work. It will not fit the standard, but the cable will actually work. It works as the signal does not care about the color of wire, only that each side of the cable is connected to the same pins on the RJ45 connector. And here is the crossover cables. One end of the wire is on a different pinout, right? So you have orange should be on 1 and 2, but now it's on 3 and 6. The green should be on 3 and 6. It's on 1 and 2, right? It's just showing that, that's crossed over, and then the next section, right, it crosses over all of the wires for gigabit. So you do a gigabit crossover cable. You cross over all the wires for gigabit crossover cable. Flowchart can help in troubleshooting a network. Just walks you through. Very first thing is pinging the devices, yes or no. And then if you can, you do one thing. If you can't, you do other things, right? And you just walk through this flow chart. I'm not going to read each option. You can definitely spend some time looking at it. But it does go through a good amount of troubleshooting on the network. Okay, the book talks about checking the hardware first, which is okay, but most of the time it'll be easier and more convenient to check Windows network settings first. Running IP config all to see what, if any, IP configuration is set on the network is a key first step. If you're on Linux, you can run the DH client-v. If there is valid information from the find the default gateway and try to ping the gateway. If the information is not valid, for example, the IP starts with 169.254, this tells us the network adapter is set to DHCP but is not able to locate a DHCP server. If we know that there is a DHCP server, then we would start checking our hardware. Is the cable plugged in all the way on both ends? Is the DHCP server on or plugged into the network correctly? You may need to check the cables with a cable tester. Also, sometimes we need to disable and re-enable the network connection, and you can do this from the Network and Sharing Center. If you have a wireless laptop, some of them have a switch that will disable the wireless card, and the switch is sometimes easy to switch off. So make sure the wireless card is turned on. Finally, you can try and do an IP config release and renew, or a DH client-v-r if you're on Linux. But definitely checking the network settings first, in my opinion, is easier than checking the hardware. You may need to check to see if the network adapter is working. So go into Device Manager and see if there are any errors. Try updating the driver as well as uninstalling and reinstalling the adapter. Also run antivirus software and perform updates for Windows. All of these could be needed to restore network connectivity. If you have local connectivity that you can connect to or ping other computers on your network or other devices on your network, but you have no internet access, you can try turning on and off the connection to the ISP. Unplug the power source, plug the cable modem or ISP device, make sure your router's on, and then try to rebuild the connection. For a cable modem, make sure your TV's working, right? Because they share the same connection. So if you've got cable TV, it's likely that you should still have internet. But if you don't, maybe there's something wrong with the modem itself. To eliminate the router as a problem, connect one computer directly to the modem and see if you can connect out on that computer. It might be the router's got a problem. If you can access the internet, then you've proven that there's something wrong with the router. I mean, it may be dead, or it may have an incorrect configuration. If you have okay, so the other thing is try to eliminate DNS as the problem. So you can try and put in an IP address in a website. If you know the website numbers, the IP. try to put in like try to ping google.com, and see if you get it to resolve, and tries to ping, try to ping your DNS server. Try changing your DNS server to public DNS servers, which, like Google is 8.8.8.8 and 8.8.4.4. If you change it to there, see it starts working, see if it's your DNS server. You could try to trace route to some known site like Cengage or Microsoft or Google, and see where the problem starts failing. Does it get to your router? Does it get past your router? If one computer cannot access internet but others can, right? Make sure your MAC address filtering is disabled, right? Or make sure that your MAC address is in the list that has access. Also, you'd be looking and seeing if there's other issues. Do you have the right DNS server settings? Do you have the right configuration? And then, of course, verify your router firewall or Windows firewall. And then if all that fails, you may need to contact your ISP to see what might be happening. There may be an actual issue with the ISP. And here is the example of checking the DNS. And this is set to the several free DNS servers provided by Google. And Google is one of the best known, right? So 8.8.8.8 and 8.8.4.4. Those are Google's DNS servers. Use your ISPs. You'll probably get yours from the ISP. It'll be set by default. But if you do have problems, you could always set it to Google's DNS. Here are some steps to follow, although I would do step 4 first. Entering the ipconfig/all on Windows or dhclient-b on Linux at the command prompt to verify IP information. I would do that. I would also do step 5 next to make sure that my TCP/IP stack was working. Then I would do step 3. I would try to ping another computer on the network, and also ping my gateway. Make sure I can get to the router, and some other. That's probably what I do first. So I would ping the router. If I could ping the router, I wouldn't worry about another computer on the network. But I would do that. I would do step 4, get my IP information. Step 5, ping the loop back, make sure my TCP/IP stack is working. Step 3, I would ping the router that I found the information in step 4. I would ping the router. Then I would do step 2 or step 1, right? So well, depending on what I find, right? If I can ping the router, I'm not going to do step 1 or 2, right? I'm able to connect to the router. Then I would try and figure out what else is going on. But my guess is if you're having an issue, you probably have an issue with after doing step 3, right? Step 3 might not work. Then if step 3 doesn't work, then I would try step 1 if it's a DHCP, or step 2 if it's a manual, and then step 6 really doesn't help here. It finds out if a program is accessing the network, is actually running, um, but that really isn't going to solve anything for us. It's nice to know. It's good to know if you're trying to find out if if you've been hacked and somebody's running something on your computer. But for the most part, this is not going to help you in troubleshooting your network connectivity. Steps 4, 5, and 3, in that order, 4, 5, 3. Those are your big go-tos. Um, you know, one, when you do 4, you get the IP address that you have, subnet mask that you're on, that you have. So what's your network? Your DNS servers, your gateway. You have all that information, and then it's a matter of, well, does TCP/IP work? That's number 5. Okay, if it's working. And 3, can I get to my gateway? If I can get to my gateway, um, and I have a valid IP address, and it works for that network, then what else is there? Then is it DNS? Um, is there some other issue, or is it an ISP issue? Um, but this is good, but I would say 4, 5, then 3, and then depending, you can do 1 or 2 if you're not able to connect on 3. Um, but that's how I would do that. And then, of course, other things to look for, firewall settings, right? So Windows Firewall, you want to make sure to turn that off just to see if that corrects the issue. If it did, then you need to fix the firewall configuration. And then 8, if you're having problems getting a network drive map to work, they list the commands to map a drive, right? So you could delete it and then remap it. But really, you need to have connectivity first. I'm not exactly sure why they included this here, but that is correct. That is how you map a drive, or delete a map drive. But you still need network connectivity first. So we'll cover map drives much later, and you'll get practice dealing with that. But it doesn't really help you in testing your network. If your network is slow or sluggish, first check with all users to see if they are doing something that is using all the bandwidth. Next, I would check that the adapter speed setting is set correctly on the system and the switch. Typically, this is set to auto-negotiate. I would set it to the maximum setting that can be handled by both the adapter and the switch. Next, look for any loose cables or cables that might have too much shielding stripped away. There should be less than 1 inch of cable stripped away at each end. Any more than that, and you can have issues with the cable interfering with itself. Next, I would use a network tool like Wireshark or Microsoft's Network Monitor to see if there was any device on the network that was causing the issue, as one of the devices may have a virus or worm or a hacker that is causing the issue. Then check on the internet and transport layers. The checks on the internet or transport layers would not help as you have connectivity, right? So, right, if the firewall was blocking ports, it wouldn't be sluggish. You would have no access. So, definitely the transport layer check that they're mentioning here does not apply. Um, and the application layer, very unlikely to be a configuration error, but it could be. I mean, I could give you a little bit on the application side. There could be a configuration that could cause it to slow down. Um, so you might want to look at the application layer, but definitely the transport layer. Um, Checking the firewall settings is not. It's not going to help you with a sluggish problem. I mean, the firewall settings are either going to block it or allow it, not slow it down. Um, so, so just in my opinion, the book is wrong here. The other parts, that's fine. The internet layer too, right? The ping, computer's loopback address, default gateway, another device. Why are you doing that? You're getting access. You're getting access. It's just slow access. So the internet layer, transport layer, they are not going to help you here. Not for slow. Um, all that is checking for connectivity. The internet layer, transport layer, that's checking your connectivity. You have that. It's just a slow problem. So the book's just wrong here. All right. So then finally, the Wi-Fi network's not found. So um, typically when you go, the Wi-Fi network is broadcasting the SSID. So if it's not detected, either the access point is down, the wireless access point is down, it's broken, not working, or the SSID may be hidden, right? So there is a way to hide the SSID. It's a security feature, and it could be hidden. And so you just have to manually connect to the network, and you just go in, set up the connection, and type in the SSID that you know it to be, and then if it is up and running, it will connect. So it could be that, but in most cases, the SSID is being broadcast, and thus, if it's not visible, there's something wrong with your access point. So that is our end of Chapter 8. The next video will cover Chapter 9, supporting mobile devices.